Distance between 2 points. How do you do it? Let's find out with the aid of the distance formula. So let's say I want to take a trip from this point right here at 3, 2, all the way over to 8, 6. I want to find the distance between these 2 points, or if I were to make a line segment here, the length of this line segment. How long is the segment? In order to figure this out, let me sketch something that might make you think. All right. So what does that look like? Let me add in a little bit of a hint. We have a right triangle. Right triangle, if I've got 2 legs right here, and I don't know the hypotenuse, I can figure that out thanks to the good old Pythagorean theorem. Well, Pythagorean theorem is just a squared plus b squared equals c squared. I can use that here, and that's basically what the distance formula is. It's another way of using the Pythagorean theorem in order to find the distance between 2 points on a plane. If I have this length and this length, I can make it work. So I'm going from an x-coordinate of 3 to an x-coordinate of 8. So if I take 8 minus 3, that's the length of this right here. 8 minus 3 is just 5. So I have a length there of 5. And I'm going from a y-coordinate of 2 up to a y-coordinate of 4. Or excuse me, 6. So the length there is going to be 6 minus 2, which is 4. So now really I've got a right triangle, side length 5 and side length 4. And I want to find out what this is. This is my c, that's the hypotenuse. So a squared plus b squared equals c squared. So it doesn't really make a difference which one is my a, which one is my b. 4 squared plus 5 squared equals c squared. 16 plus 25 equals c squared. That's 41 equals c squared. And that would be the square root of 41, which is c. That's it. See, all right? All right. But we're not going to use that just by itself. It gets a little bit untidy. We want to have one thing that we can kind of plug stuff in. I mean, you could make that work. But the distance formula is actually going to look something like this. Your distance, d, is equal to the square root of x2 minus x1 plus y2 minus y1. This is the distance between the two. And then we square that, because this is just like the sides of a right triangle. We can plug that in here. My distance would equal the square root of, and also quite technically, it really doesn't make a difference which one you put first. You could put x1 here, then you could put x2. You have the minus, so you could get a negative. The difference between the two is going to be whatever is here. And whether it's positive or negative is not going to make a difference because it's squared. When you square any negative number, it becomes positive. And if you square a positive number, it's going to stay positive. So don't fret too much about the order. I can plug in here. So I've got the x2 that I want to use, 8 minus 3 squared plus 6 minus 2 squared. Simplify, 8 minus 3, 5 squared, 6 minus 2 becomes 4 squared. Oh, looking a little familiar here now, huh? Square root of 25 plus 16, square root of 41. Just like we saw over here. The only difference is this is in a slightly different format, but the same concept is at work. We are using the Pythagorean theorem in order to find the distance between 2 points on a plane. That's it. All right. Practice this out, and let me give you a distance to find here between 2 points for some practice. Let's find the distance between, oh, let's do negative. -2, 0, and 4, 3. All right? Test that out, play around with it, see what works, have fun.